Hello, my name is Kyle Lake, and thank you for joining us for this webinar today on HyperLynx DRC and how it is a powerful, customizable, and fast design rule checker for common issues for SI, EMI, and PI issues in your printed circuit board design. So today we'll try to cover how to get your PCB design into HyperLynx DRC from any layout tool. HyperLynx DRC can bring in ODB++ files from most major CAD vendor tools. Then we'll talk about how to edit these rules in HyperLynx DRC to check the issues that matter most to you. After we run those rules, we'll be able to create reports highlighting the issues that need to be fixed that include details about each issue that has been found. Finally, we'll be able to talk about how we can execute rules that have been predefined from different schemes in your HyperLynx DRC project. So you can set the rules up once and carry those rules from project to project. A little bit about Oasis Sales if you are unfamiliar. Oasis Sales has been a Mentor Graphics partner for over 18 years, and we are proud to help our customers find solutions in printed circuit board design, printed circuit board simulation through HyperLynx, as well as FPGA design and simulation and circuit or harness design. So we are based in the Midwest, and we cover the Northwest of the United States as well. So down below you'll see the states that we service, and if you reside in any of those states, please feel free to reach out to me after the webinar in order to receive any more information about what we talk about today, or perhaps evaluate the tool, or even receive a quote. So we are also pairing with TriLogic in this webinar series. TriLogic is our counterpart on the East Coast. And again, they have been an EDA reseller for over 30 years, specializing in the same areas that Oasis Sales does as well. So they support Mentor Graphics as well as Omnify. Omnify is a powerful PLM and data management tool that can pair very nicely with some of Mentor Graphics tools. They are headquartered in Andover, Massachusetts. And again, you'll see down below the states that they service. And if you reside in one of those states and are unsure who to contact within TriLogic, please feel free to reach out to me after the webinar, and I will get you the correct contact information for your contact within TriLogic. Here is just a graphic showing our respective territories. Again, Oasis Sales covers the Midwest as well as the Northwest side of the United States, and TriLogic is based on the East Coast and Southeast. If you like what you see today, please feel free to check out our other webinars that we have done on our YouTube channel. You can find that at the link there, or if you like, you can go to oasissales.com and find our YouTube channel on our website, as well as trilogic.com. We'll have a link to their respective YouTube channel with their archived webinars as well. Okay, so I just want to throw this out there for my next webinar, which will be in just a few weeks on Thursday, November 1st, the same time as we are hosting this today, 8:30 a.m. Pacific time. And what we're going to be covering there is actually how to run Valor NPI and HyperLynx rules directly within Expedition or PADS Professional layout. Okay, so today we'll be actually running those rules directly in the standalone application, but I will be showing how we can actually run those rules in the CAD tool themselves. Okay, so here's my contact information. Please feel free to write that down, take a screenshot of that. I'm always happy to answer questions with what we discussed today, or maybe evaluating the tool, or able to get the contact information for your respective salesperson. All right, so again, everyone is on mute that is in this call today. So please feel free to answer questions in the chat box in the GoToMeeting client. Hopefully you're able to see that. If I don't get to your chat questions during our discussion, I will definitely reach out to you via email after the session is over. Okay, and with that, without further ado, I'm going to go ahead and hop into the actual webinar talking about how to use this powerful, customizable, and fast design rule checking with HyperLynx DRC. But before we hop into the actual meat of the webinar today, I just want to give a general overview of the tools that Mentor Graphics can offer you for your electronics design. So Expedition Layout is an enterprise-level PCB tool that offers very high capability in the layout tool, as well as data management capabilities and concurrent design capabilities. So multiple engineers can be working on the schematic or on the same layout in different locations across the country. If you have a multi-site organization, you can collaborate with the same data at the same time. Okay. PADS has been around for a very long time. It's more of a project-based desktop PCB design solution. Still a very capable layout tool. People are designing some very high-end PCBs with PADS. It just doesn't include that concurrent capabilities or the data management wraparounds that Expedition offers. HyperLynx, which what we'll be talking about today, is a family of PCB and analysis verification tools. Okay, so with HyperLynx, we can actually simulate analog signals in some fashion, as well as digital signals. And today we'll actually be talking about how the DRC is able to do a graphical rule check for common EMI issues. And then lastly, but not least, we have Valor, which is on the manufacturing and assembly side of printed circuit board design. And what that includes is manufacturing and assembly checks for your design to ensure that it'll be the highest yield possible. Okay, so if any of those sound interesting and you're not familiar with that, please again, feel free to reach out to me after the webinar. I'd be happy to discuss any of those solutions. Okay, so I just wanted to give a general overview of what is available within the whole HyperLynx family of tool suites. Okay, so HyperLynx is, again, allows you to do multitude of simulation on your design. So there, in the HyperLynx SI realm, we have two tools that allow you to do what-if analysis and simulate your SI and PI needs. Okay, so LineSim at the top there is really a what-if SI and PI analysis environment. Okay, so with here, we are really able to look at our interconnect design on a whiteboard environment. You can sweep different parameters. You can adjust parameters to see what will be the best way to set up your design rules in order for your signal integrity to be as best as possible. Okay, also within here, we are able to set up a power distribution network, or PDN, and see how the sources, loads, and caps and metal structures are going to affect how well your PDN operates. Okay. And then on the post layout for SI and PI verification is the board sim tool. What the board sim tool does is it actually brings in your fully placed and routed board and allows you to do batch simulation for SI and PI analysis. But what we'll be talking about today, again, is HyperLynx DRC, and that is another tool that you can see down there on the bottom right. It brings in, again, all of your stack up, all of your component placement information, as well as routed trace information, and allows you to do some electrical rule checking that is fully customizable and is graphically based. Okay, so just a little bit more about HyperLynx DRC. It automates the design checks and eliminates the errors from manual inspection for EMI issues. So in the past, usually in the design checkoff stage, it would be passed to the EMI expert who would maybe go on a layer-by-layer basis, checking for common issues such as traces crossing gaps, layer by layer, in order to find those types of issues. What HyperLynx DRC allows us to do is fast check these very quickly by a graphical inspection. Okay, and I do see one question from David. Can DRC use both TCE or ODB++? And that is correct. So the best way to bring in a design file from any CAD tool into HyperLynx DRC would be ODB++, but it also can use TCE directly from Expedition or PADS Professional Layout. So again, it does include built-in rules, and these rules are for EMI, SI, and PI issues. I will go through a full list of what the rules check at the end of this presentation. I won't be going through in detail on all of them because there are quite a few. There is also a licensing level that allows for customers to actually customize these rules. So we can take the out-of-the-box rules and actually customize or tailor them to do a new check that's similarly based, or we can actually write an entirely new type of check that can be used in the HyperLynx DRC tool. Okay, so what are some common issues for EMI? And I'm just going to show how HyperLynx DRC can kind of help identify these and fix these issues in the layout tool. So major causes of EMI in printed circuit boards is traces crossing plane splits. So as soon as that happens, the reference plane and the return current path is going to be blocked by this split in that reference plane. So the return current is going to have to radiate around and find a closest return path that it can, and that's really leaving a lot up to chance. So this will identify those very quickly and allow us to see if that's going to be a huge issue. Okay. Also, we can identify if traces are referencing the wrong voltage plane, and if there's any signal vias without nearby transition vias, again, for that return current. Okay. What do all of these issues have in common is that the current is not traveling in a closed loop, and that's very difficult to simulate, almost impossible to actually simulate in a typical simulation environment. So this, again, for those types of issues is going to be graphically based and identify those so you can make the engineering decision on how to fix those the best. Okay, so here's just actually some items that we can actually simulate in the simulation world. So signal integrity, of course, we can simulate overshoot, undershoot, crosstalk, timing, and use eye diagrams and bit error rates to identify those in the digital realm. Okay. Power integrity, we can again look at decoupling, the actual voltage drop, and the plane noise. So all of these things can actually be simulated in the HyperLynx SI world. Okay. But things that are very difficult to actually simulate would be return current path issues that we've already discussed, nets that are being routed very near plane edges. So this can cause issues as well, and this next slide will talk about that. Or IO nets coupled to fast signals. So obviously that's going to cause some issues by radiation on that slave net, and then a proper filter placement. So we need some other solution other than just simulating these brute force way. Okay, so here's just some examples of what would constitute as a break in the reference plane. A hole in the plane. This could be as simple as overlapping anti-pads if you're routing a trace very close to that. And there's overlapping anti-pads that will not allow that return current to run directly under your signal. Deviation in the return current path, and then just general radiation overall. Okay, and then what we would consider a split as opposed to a gap in the plane is a large deviation in that return current path. That can cause a voltage drop in the return current path, which ultimately leads to some ground balance issues. Okay, this again generates common mode current, which can be a very difficult issue to tackle and ultimately causes EMI. So this could cause you to fail your EMI check once your design has been fully created. Okay, so why is it an issue for us to be wary of routing traces close to the reference plane or the edge of that plane? So you can see in the top right, that is actually from HyperLynx in the field solver. You can see the electric and magnetic fields that are created while that signal propagates down that trace. And you see if the reference plane is fully intact under that, all of those electric and magnetic fields are fully coming into contact with that reference plane, and everything looks as it should. Okay? But if it's running next to the split in that reference plane, you can see that those fields are being stopped by that reference plane on one side of that trace, and then the other side, they're propagating through because there's no direct reference underneath of them. Okay? So this can affect the field distribution and affect the impedance that that trace ultimately sees. Okay? So these are both things that HyperLynx DRC can check for, which with manual inspection would be very error prone and difficult to track down as a simple issue like that. Okay, so just some common issues that are close to that is just routing too close to the edge of the board. Of course, if you're routing very close to the board edge, you might not be over a solid reference plane. And then just any large void in the middle of the board. If you're routing close to that or right over the top of that, again, the reference plane is not going to come fully in contact with it. Okay, so signal vias. If we are transitioning from one layer to another, we do need to take into effect our signal vias as well as any other vias that we might need for stitching those planes together. Okay, so these just add complexity to our return current path or the current loop. Okay.
So these can inject noise direct into that plane, and we can also have via-to-via crosstalk. So again, these are all issues that we can look at. There's a check for maximum number of vias that you can set in order to kind of curb this type of issue. Okay, so what does HyperLynx DRC really look like? Okay, so on the screenshot here, you can see what the interface for HyperLynx DRC looks like, and essentially there are a few different windows that are kind of important here. So we've got the board display, actually shows what your routed and placed board looks like. Again, all that stack up information is brought in directly from either that ODB++ file or the CCE file, which is translated directly through Expedition Layout. Okay. So again, there are built-in rules into the tool, depending on your licensing level, how many you have access to. And then we are, in one of the licensing levels, you also have the ability to create those custom design rules to identify your issues that you are most concerned about. Okay. What this allows us to do is set this up, adjust the tolerances or how the rules are checked, and create those as our schemes. So this way you can use these to check multiple designs with the same setup. Okay, so what this does is it automates the design process. It makes everything consistently checked, minimizes the human error, and hopefully will reduce the design review time so you don't have to have a bottleneck with your EMI expert checking for these types of things. So just a quick slide on the different licensing levels that we have within HyperLynx DRC. So there are essentially 3 licensing levels within HyperLynx DRC, and that's going to be developer, which is coming with all of the rules, so 40 rules there. It allows us to write and run those custom rules that we've been talking about. So you can kind of see the breakdown between these different licensing levels. We've got developer, standard, and PE, or personal edition. So you can see the respective number of rules in each category that they would have. Okay, so I'll just talk a little bit about this. This is actually showing every rule that would be included in the highest licensing level, again, that developer license. So these are all the rules that you have in EMI. We can have exposed length, metal islands, nets crossing gaps again, signal supply, and return path. Power integrity, we are actually able to check for decoupling capacitor coverage, as in, are there enough? And placement, as in, are they placed well? Okay, so we can also look at the decoupling vias, the power and ground width, and the overall vias within your PDN, or power distribution network. And then on the SI world, we are actually able to look at a couple of different things that can be very important to verify. That would be crosstalk coupling, differential impedance. We are actually able to make sure that your differential pairs are meeting your assigned differential impedances. And then many vias, again, we can check for that, and an actual termination. So these are actually running some SI type checks in the background for these DRC rules. Okay, so once again, I am not seeing any more all right. Okay, so with that, I'm going to go ahead and hop into the demo. So again, if you have any questions while what I'm going on, please feel free to ask those in the chat box. I do see a few in there, and thank you for those. I'll follow up with those in private. Okay, so again, there are a few different ways that we can actually bring the design into the HyperLynx DRC realm. So right now, I have a board that's been mostly routed and fully placed in PADS Professional. So PADS Professional, if you're unfamiliar, it is very expedition-based in the layout tool. So if you're familiar with this, or if you have questions, please feel free to reach out to me. So in order to kick this over to the HyperLynx DRC tool, all I have to do is go Analysis, Export to HyperLynx DRC. Okay, so what this will do is actually export a CCE file, or CCZ file, excuse me, and that will bring that in directly into the HyperLynx DRC realm. Okay, so the splash screen will pop up. If you have multiple licenses that you can choose from, you'll be able to choose your licensing level. For the sake of this, I'm just going to go ahead and use that developer license. All right, so if we bring this in the first time, we'll actually be able to see what our design kind of looks like in this board viewer. Okay, so it does bring in our entire stack up as well as net information. The first time that we do bring this into HyperLynx, we will have to go through a project setup wizard, which allows us to set our units as well as make sure all of our differential nets and net classes have been brought over correctly, as well as design rules. Okay. So the first thing I want to check once we have this brought open is the actual stack up that's been brought over. So you'll see this is the stack up editor that we can work with, and it looks exactly like the stack up editor that you can utilize within Expedition or Past Professional, so it should be very similar to you. It's always just a good idea to make sure everything looks correct in here, but it should bring in all your stack up information correctly directly in from that layout tool. Okay. And that would be the case if I imported an ODB++ file from any design tool and bring that into the HyperLynx DRC realm. Okay, so we can also look at our project data. You can see that we have brought in all of our layers. We can actually look at all of my different signal layers in the board. If I click on them, we can see all of the properties that are assigned to them in the bottom left-hand side of the screen there. So it gives all of our different properties to the associated layers, as well as components. We have all of our components that have brought in. This is cross-probable, so you'll see as soon as I select a component, it gets highlighted in the board viewer. I can do multiple selections and just take a look and see their properties again for all of these different components. Okay. Again, it will bring in all of our different net classes that we have defined in the layout tool, as well as constraint classes if you have any of those. All right. So it does bring in all of our design data from our CAD tool. The next thing I want to take a look at is just take a look at the rules that we can actually work with. Okay, so here are our rules that we can work with. We have EMI, PI, SI, and then any custom rule sets you've gone ahead and created for yourself. So first we'll take a look in our EMI rules. So I can expand this and actually see what our different rules and checks that would be. Okay, so I know I saw a few questions on what does this particular rule do, and I'm sorry I don't have enough time to go through every single one. But if I want, I can actually click on a rule, and inside of the tool, it will pull open a little bit more information on exactly what this rule is checking. Okay, so for example, in this return path, it's checking for trace closed loops. Okay, so any type of loop that's happening in your return current path, it's going to flag those. All right, so it gives us a little bit more information on the parameters that we can actually go ahead and set for this rule to ensure it's going to be checking exactly what we would like. Okay, so those are the parameters that we can actually play around with. And if I expand the parameters tab, we can actually see that we can edit these different values. Okay, so these rules all do come with settings right out of the box, but it is always recommended to understand what the rule is checking, understand what you would prefer for your tolerances to ensure that you're going to pass your EMI checks. All right, and if we actually need more information on how this is going to be flagged as a violation, I can click on the violation conditions, and this is actually going to give us more information on what exactly is going to be flagged as a violation. Okay, so all directly within the tool, it's very easy to understand what's being checked and what will actually be flagged as a violation on our design. So that's EMI. Also the ability to check for our PI rules. So again, we've got some decoupling capacitor coverage, placement, the via location, the order. But if I actually want to take a look at our decoupling capacitor placement, this is going to check the decoupling capacitor placement in a circular radius closest to the ground and power pins for your components that you would like to have checked. Okay, So there are some prerequisites. We need to have object lists for the ICs. Of course, we need to make sure we identify which ICs we would like to have checked for their power pins, and then also have our capacitors defined there as well. Okay, so essentially here we are going to be defining the maximum distance from the pin to the capacitor, as well as the maximum search distance in that radius of that circle. Okay. All right, so again, this is all directly within the tool. Really easy to just click on these different rules, hopefully understand if you even need to check for them. It is not recommended to go ahead and just run every single rule on every single net in the design. That would take a long time to simulate and a long time to output all of those results. Okay, so it is recommended to go ahead, take a look at these rules, understand what they're checking, and see what you would need to actually use to sign off on your design. All right, and lastly, but not least, we'll just go ahead and take a look in our SI. And SI does have quite a few different checks, but we'll just go ahead and take a look at differential impedance, for example. This just checks for deviations in differential impedance across those two traces. Okay, so we can actually go ahead and define the tolerance, the minimum length that they are out of that tolerance that we have defined, as well as that target impedance. Okay, so this will check all those and allow us to quickly identify those. Okay, so that's just a quick overview of all the rules. Again, if you have any direct questions on a specific rule, please feel free to email me after this, and I'd be more than happy to discuss what these rules do in more detail. Okay, so like I said, it would be unwise to go ahead and run all of these rules on every single net in your design. That's going to cause probably a lot of false errors in general, as well as a long time to actually check everything on the board. So there's a couple different ways that we can actually go ahead and tailor these rules so they don't check everything on the design. Okay, so for example, I could actually go into a single rule and take a look at ICs over split, for example, and in the applied to section in the properties, we can see that this is applied to the entire design. If I wanted to, I could go ahead and just apply this rule to a net class or a particular component or an actual electrical net if I knew exactly which net I wanted to check this for. Okay, so in the drop-down list, this will actually give me all of the nets that I can check in the design. Okay, so those are all brought in, again, from our design files from our CAD tool. All right, another effective way to kind of ensure that the rules are only checked on what nets you would like, I can actually go ahead and set up an object list. Okay, so object lists are either system object lists, so they'll automatically be created from different components, physical nets or electrical nets if we have that. So for components, I can have an automatic object list of capacitors. It's just going to look at the reference designator and assign those capacitor reference designators into our component object list. But if I want to create my own custom object list, very easy to do. I just go to the User Object List tab, and I can right-click on the user object list, just hit New, and that's going to go ahead and create a new rule for me. All right. If I wanted to go ahead and rename this, I'm going to use the Properties tab below, and I can call this DDR check. Okay. Only DDR nets for this particular one. I can enter a description, and actually go ahead and begin assigning nets. Okay, so again, I'm creating a user object list so I can limit the rules to run only on this object list. So for this object list, I only want to be working with electrical nets. Okay, so easily enough, just like how I would create net classes or constraint classes in your CAD tool, I can just select my different nets and push them over into this list. Or as a more automated way, I can actually go ahead and do some manual assignment of nets into this object list. Okay. All right, so this allows me to essentially cause or create new conditions that would look at all the nets in this design and automatically assign them to this object list based on these conditions. So what I can do here is if I take a look at the name of the electrical net, and if it contains any of the following text that I enter, it will automatically be placed in this user group. Okay. All right. So as soon as I type in what I want this to be, we should see the nets auto-populate in this object list. Okay. So any net that contains DDR in its net name is automatically going to be placed in this object list, as you'll see here. Okay. So this automatically pulls all those nets in, and we've gone ahead and created our DDR check object list. This list is cross-probable. I can actually cross-probe directly, and you'll see that it highlights that net or that trace on the design space. All right, so I've gone ahead and created my object list. Now we can actually go ahead and begin running some rules. So if I want to take a look at my EMI rules, again, I want to check, I'm going to actually click on the EMI in total, and now any EMI rule that I run, I only want this applied to this object list that I just created, and that object list is going to be DDR_check. Just created that one. Okay. So now any EMI rule check that I place or that I run will automatically only be applied to my object list for DDR nets. Okay, so I'm just going to go ahead and begin clicking on some of these. Again, if I wanted to adjust some of the parameters, I can just click on that rule and come in here and adjust the parameters. It is suggested to take some thought into this, see what you would need to put in on your designs, and make sure that that is set there. Again, once you set that up, you can share all this rule setup between HyperLynx projects. Okay, so just for the sake of this demo, I'm going to go ahead and check those checks in the EMI space. And if I want, I can actually go ahead and again set PI to just that object list for DDR check. All right, and lastly, just for the SI rules, I'm going to go ahead and once more change this to just that object list. All right, so you can see on the Project Explorer in the rules section, all of my checked boxes with little asterisks on those folders mean that there's some sort of rules being ran on that object list. Okay, so now just to execute those, all I have to do is right click on the rules and hit execute rules. So while these are happening, the output window will start showing us what is happening during the rule checks. So you can kind of see right there, it shows that 39 violations were found for the net crossing gaps. And you can actually see in the Project Explorer a process bar on how those checks are going and how long it might take to run all of these. So you can see with just these limited amount of checks, it's going to take maybe a minute or so just to run through all of these, but that's why it's probably not recommended to go ahead and run all of your rules on all of your nets in the design. Okay, so down below you can actually see what it is processing while it's checking that rule. So let's just go ahead and give it a second, and it should move through the rest of these rules once it's done with the PI fairly quickly. All right, once again, I'm not seeing any new questions. If you do have any questions, please feel free to write those in the chat box. You see one question from Ken Cantrell. Hi, Ken. What size memory do you need? Actually, so that's a good question. For this, I don't know of the actual recommended, but more than 8 gigs really isn't necessary, and I think that's standard for most users lately. Okay. All right, so once our rules have been executed, just some color code kind of understanding what's going on here. So if I actually look at my rules, you'll see that anything within red just means that some sort of rule has found violations within your design. So if I expand that, we can take a look. I'm actually going to go ahead and make sure everyone's muted. Okay, so anything that we see red is going to be showing that there are some rules that have actually failed or caused violations within our design. Okay, so I can just take a quick look at my different results and see what's actually caused violations. Okay, so what I can actually take a look at is in my last run, in my violation section, I can actually take a look and see all of the rules that have failed. All right, if you just joined in, I'm trying to mute you, but okay. All right, so in my last run, when I have it selected, this will actually pop open to see all of the violations that we had during that last run. Okay, so in here, we'll actually get a description for what rule was checked for that. So if I just single click on one of these, it's going to go ahead and zoom in directly to that section where the rule was violated. Okay, so it gives us a lot of information within here. It gives us the severity, which we can actually tolerate. I can click on the status, and one by one, I can actually go ahead and say to be reviewed, okay to ignore, fix as possible, or must fix. So if it's a very significant error, I can click that must fix, and when we generate our report, that'll be on there to notify whoever's looking at that needs to be fixed as soon as possible. Okay, we can also enter in any notes that we have to ensure what our thought process is on there, and then also just general information for which net was causing the failure, the physical net, the signal layer that it was on, and then the reference layer that it was actually referencing during that simulation. Okay, so we have quite a few crossing splits. I've got some target impedance errors that I can take a look at here. So if I click on that, just on the right-hand side, it gives us some different actions that we can look at. I can zoom to that violation, highlight that net, and zoom in. If I'm not already zoomed into it, I can undim the entire design if I wanted to, or I could actually clear everything. So it gives you some advice on maybe how to fix that. So we can adjust the net width maybe to look at this impedance. So it says we're below the target impedance for that differential pair. So maybe we can take a look at how that was actually routed together, the differential spacing, the differential width trace width for those differential pairs, or maybe the actual stack up that we utilized during this design. Okay. So again, I can once again change what the status is. If I can, that's fine. We can ignore that one, and it will not show up on a report if necessary. Okay. So once we've gone ahead and ran our rules, we actually can go ahead and look at generating a report. All right. So if I want, I can go ahead and select all of my different rules that I want to actually export onto my report. So I'll select quite a few. And what I want to do is first create a new share list. I'm going to create a share list that allows me to actually create this HTML file. So what this is going to do is create an HTML file report for all of these rules and allow me to share it with my colleagues with images and with all of this information on here. Okay, so I clicked on the icon to add those to all of my share list, and once that has been created, I can actually go ahead and export this share list. All right. So what is output in the share list file is all of these image files as well as an HTML file that kind of concatenates all of the data. If I just double click this HTML file, it should hopefully open up for us in the web browser. And I'll kind of take a zoom out here. So this is actually all the information that's been brought out on our share list or HTML report for our DRC checking. Okay. So as you can see, it's got essentially all of the useful information that would be helpful in going back to the layout tool and maybe taking a closer look at all of this information. All right, so it gives us the net, the signal layer, as well as the rule that it was violating, and the XY location, which can be very useful in actually tracking that down in the CAD tool. All right, so I do see a few questions, and I will get to those privately after our session today, I think. But with that, that's all I was going to show today. There is a bit more to HyperLynx DRC, so if you have more questions or want any other information on this tool, please feel free to reach out to me. Again, here's my contact information. Please feel free to take a screenshot of that or jot that down. Always happy to help people out understanding what we offer for solutions. Okay. And the last thing I'll talk about is just, again, save the date for my next HyperLynx or my next webinar, which is, again, just in a few weeks, same date, same time, 8:30 Pacific time on Thursday, November 1st. And I'm going to be talking about running Valor, NPI, and HyperLynx rules directly within the Expedition layout tool and why that can be powerful. Okay, well, thanks again, everyone, for attending, and let me know if you have any questions. Have a good rest of your day.